investigating force, mass, and acceleration. In this tutorial, we'll learn about an experiment that shows the effect of force and mass on acceleration. This experiment is on page 24 of the book, figure 3.3. In this experiment, we have a bench and a ramp that has a specific slope. The slope is intended to overcome the friction in the trolley's wheels. And we have the trolley that has loads on it. It is attached to a nylon line. On the other end of the nylon line, we have the mass hanger. On the side of the bench, we have a pulley. This makes the nylon line's movement easier. We start the experiment by taking loads from the trolley and putting it on the mass hanger. This load will make a vertical downward force and pulls the trolley. We take one load from the trolley, hang this load on the mass hanger. This load will make a vertical downward force. We keep on repeating this step to see the effect of force acting on an object on its acceleration. Transferring one of the masses from the trolley to the mass hanger increases the pulling force while keeping the total mass of the system the same. That's why we don't introduce mass from outside of the system. Now we can measure the force of each load using a spring balance. We have discussed how this works in a previous tutorial. Now, how is the acceleration of the trolley measured in this experiment? We have two methods. The first method is using the light gates and data logger that are used in a modern version of Galileo's experiment. We have talked about this experiment in the previous chapter. Now, the light gates and data loggers can be used to find the speed of the trolley near the top of the ramp and near the end. This way, we measure the initial velocity and the final velocity of the trolley. Therefore, we can calculate the acceleration using the acceleration equation. Acceleration equals final velocity minus initial velocity over time taken, or v minus u over t. Then the acceleration of the trolley caused by a particular force will be found. We can repeat this when we change the loads on the mass hanger at the end of each step. Now, the second method, we can use a digital video camera to take a series of pictures at equal time intervals. This way I can get the distance at each picture and I have the time, so we can draw a distance time graph. In chapter 1 we mentioned that the distance traveled by the trolley from a start at a particular time interval can be drawn using a distance time graph, and the slope or gradient equals the speed at a particular time in a distance time graph. So after we get the speed, we can draw a velocity time graph, and the slope in the velocity time graph equals the acceleration of the trolley. We can repeat the experiment by changing the loads, meaning changing the force to draw a distance time graph and get the speed at a particular time, then draw the velocity time graph to finally measure the acceleration. And then the acceleration of the trolley caused by a particular force will be found. Then we can draw an acceleration force graph.